morning. I'm Tony Jones, Principal Technologist, Mediakind. And today, I'd like to go through some of the work we've been doing at MBA and beyond. Nick has very well laid the scene before you all about how the rights work and how diverse different strata of the markets are and what they need. NBA, across many years, has been pioneering in some of the major changes in the industry, and that's equally true for when it comes to streaming. So when we come to talk about sports, there's some specific characteristics that we need to know about. So first of all, the events are very dynamic. The events happen for a period of a couple of hours, and then they disappear again. So, oops, this seemed to have gone too far. Just hit back a sec. There we go. So we've got to deal with the fact that you don't want to have infrastructure that's being paid for continuously when your event only lasts for maybe 2 hours. In fact, a sports coverage is longer than that because obviously there are setup periods as well, and teardown, and so forth. The audiences are colossal. We're talking certainly millions of viewers, and that brings its own scale challenges as well. So we've got scale happening in the dynamic sense in both the content and also in the viewership side. So they're happening together. And that tends to naturally take you towards thinking about a public cloud-based solution so that you're minimizing the cost of the infrastructure and not paying for it continuously. Obviously, you could build your own data center and do it all on premises, but then you'd be paying for it 24/7. So some numbers then. The NBA season is 7 months long. And so that means that there's a condensed period of activity followed by nothing at all. So again, a good reason for not wanting to pay for that infrastructure continuously. During that season, there are 1,230 games that were aired over this last season that's just gone. And even more than that of non-game events as well that all get streamed to the consumers. That means that there were a total of something like 11,500 productions that took place over that period, each one being stood up and torn down dynamically. So you can see the sort of scale of what we're talking about. And the other part of the scale is, of course, the audience. So we're talking about over 1 million of paying subscribers, that's monthly paying subscribers, and about 2 million of ad-supported free subscribers as well. So to Nick's point, getting people to come to the platform and engage, that's the free tier that does that, and that's paid for by advertising. But if you don't want the ads, then you pay the subscriptions. So in terms of the content flow, this is basically what we need to do. It looks pretty simple, right? So you've got multiple events happening in multiple locations across the US. Each of those brings multiple feeds in, multiple productions coming through. They all need to be encoded, packaged, targeted for advertising. It needs to be recorded for start over and also for on-demand, highlights packages, and all made available and protected and secured from the content point of view. The rights for this, for the NBA, are over $4 billion a year. So protecting that content means that DRM features quite highly on that. You don't want to have revenue leakage for that. If you want to do that in a dynamic way, you are not going to achieve that without automation. So you need to bring in something that instantiates everything that you need on demand without having to have lots of manual operations. I think you heard a bit earlier about doing things yourself. Well, you could. If you do everything on premises, then it's your problem now to keep all the software up to date and the same version. It's your problem to make sure everything is configured correctly. In the cloud world, it brings in so much more automation that you set up what you want to do, and it's very easy to replicate it time after time after time. And so what this does, it's got a level of orchestration in here that watches an event schedule, and that event schedule populates both the publicizing of the event's availability for the program information, so when you go to see what events are coming up, so you can sign for it, pay for it, be reminded about it, all that kind of thing, and of course be entitled. But also it instantiates all the processing chain that goes with it. So as you can imagine, there are a few of those taking place. But you need to know what's happening. In the old days, if you're doing things at a small scale and doing it in a predictable manner, you could put analyzers on things quite easily. You could reach things, touch things, test them. When everything moves into a public cloud environment, your world is a bit different. But fortunately, there's some really good tools that mean it's possible to have a good insight into what's happening. And The two things are, first of all, you have to be able to collect metrics. Metrics are all important because they're your gateway into understanding what's happening in the world. If your service isn't going out on air, C-rate-R, for example, you can have some pretty serious problems on your hands. So you need to be able to diagnose what's gone wrong, because things will go wrong. We're talking about the real world here. Things do go wrong. So you need to be able to somehow find out what was the cause of it, resolve it, and be able to do that in a predictable and scalable manner. So Prometheus is a software component that's available pretty much with every Kubernetes cluster. If you're doing a cloud environment, it's true whether it's a public cloud or whether you're doing something like OpenShift. It'd be a typical collection for metrics. So that gets you your data, and then Grafana is its kind of buddy that allows you to visualize it. And this is a place where a lot of customization of dashboards can take place, so it works for the business needs of the end user. So let's have a look at some of the dashboards that are being used by MBA today. So the first thing is, you can see what's happening in terms of emission data. The first two graphs at the top of the picture here, there's a left-hand side and a right-hand side. That's because MBA content is really, really valuable. So you don't just do it once, you do it twice. You do it in two different regions that separate, and if one fails, you're still on air. You haven't lost any subscribers. But it allows you to keep that redundancy in a way that broadcast would work, right? So it's very highly redundant. As it steps up, that's the number of channels which is increasing. And as you can see in this case, it's going to something over 100 channels that are set up over time and torn back down again. That's all driven by the automation. Below it, you can see some bit rates in terms of segments being published. So that's video streaming segments, and also the manifests, which are being sent individually to the different subscribers, because you're going to target them with advertising. Again, you can see left-hand side and right-hand side, so you can see if there's a particular issue in one region or not, but you can see the level of traffic that you've got. This obviously gets scaled up massively once it goes through the CDN. This is publishing to the CDNs. So what does this look like? If we say we've got these many channels going on, this is what happens. And you can see they're in batches of kind of 6 or 7. That's because once you move to streaming, it's not a case of doing a like for like. You can do a lot more in a streaming environment than you could ever do with a linear broadcast. And the reason that there are 6 here is because every single game gets 6 different productions going through. Actually, there are a few more now since it's beyond where this was done. But you can see that each one has to have its own chain, it has its own production, it has its own content. This allows the consumer to decide what view and commentary, that sort of thing they want. Much more personalized, much more targeted, and much more value add. And that kind of brings some of the differentiation that can happen into the market. For every one of those, you're also capturing the live to VOD, so it goes straight into being available as a replay. It goes into highlights, and it becomes an on-demand asset, again, without any more transcoding, so it's kind of the original content just gets stored away and becomes available immediately. In band, there's also some metadata streaming metadata going through that has a time to the clock on the game itself, so you can tie metadata, what's happening, and scores to exact times within the stream and within the game. You'll notice that at the start of each of those, there is sometimes something that's a bit yellow or red. That's because there are real-world feeds that need to be set up. Sometimes it's not being connected. This gives you visibility of what's going to happen. And this is why those event windows are longer than the actual game is on air. You heard a bit earlier about you don't want to kind of tune to something and go and watch a game and find it's not available as a streaming service yet. You need to have something on air first. So, yep, you get a barker that goes out before the main event, but you also need to make sure the production environment is all fully working and ready to go live on air before it does go to the consumers. So the processing chain is stood up some considerable time beforehand and checked out, so any missing feeds are identified and corrected. By the time it goes on air, it's fully green. It's had a chance to be checked out and made sure it's robust. We also care about how much money we're spending, because again, this could be quite expensive. So we need to have a look at the business analytics of this. So with all these servers we set up, whenever we spin up a server to do a function for any of those processing nodes that you saw, sometimes it may not be doing anything. and that's costing you money. So ultimately, you need to be able to translate what you're spending in terms of resources that you're asking for from the cloud provider into some sort of idea about how much it's costing you, because it might be that you're not using it very efficiently. So you want to have a look to see, at least at first glance, it's not your final bill, but it gives you an insight at a business level about how well that cloud resource is being utilized. Then you get into reliability. So we talked about the two regions. That's great, you've got A and B. What about your sources? So typically, for feeding into a public cloud environment, you'd use something like SRT or one of the other reliable protocols to connect into that world. And you do that because it's relatively low latency, it's got retransmission, so it'll deal with lost packets, which is what you like to get in those networks. But still, stuff goes wrong, right? So this dashboard is giving you an insight into each of those two streams. They should be identical. They should be constant bit rate. And this will allow you to see, obviously, if there's something that's happened to that stream. Again, that's an important fundamental. Is the stream there? You're trying to diagnose what's gone wrong. Is it my input? Is it my processing? Is it server? It could be anything. But these dashboards and metrics gathering give you a good insight into being able to diagnose what it might be. But of course, you might have that connection. Is the video there? Next question. It could be black. It could be color bars. It could be some noise pattern. So look at what's contained in that video stream is also interesting. So with all the encoders, we get a complexity metric. So this is all part of the process of encoding. We understand what's happening on the video that allows us to guide encoders about how to best encode a given picture. We acquire these metrics in real time as it goes through. So we've got a good idea about how difficult or easy a piece of content is at any time. And we can bring that back into the dashboards. So again, you get some sort of view into the video stream about what's happening. You wouldn't expect this to be flat. If it's flat, you've almost certainly got a problem. But this gives you some idea about the level of criticality. If it's right at the top, it probably means you've got a lot of noise somewhere and something different has gone wrong. But you would expect to find a fairly natural pattern like this, that there are periods where it's much more intense activity and complex motion with periods where it's a bit simpler. But it gives you some sort of comfort factor that you know what's going on in the content. So again, my video's gone black. Is it the source? Is it the encoder? Is it somewhere downstream? It gives you some insights into what's happening. We can also get some insights into what formats are coming in. So one of the things that might happen, for example, is you might be perfectly configured, you might have the right video set up in production, might be there, but somebody's actually configured it incorrectly to be 720p. It's one of the few manual operations that you might have on the front end could have gone wrong. It could be the wrong frame rate, or it could be the wrong resolution, wrong frame rate, or something else. So again, we can get another level of depth into this to get some operational metrics to see what's going on. So as you can see, you combine that with the metrics that you get anyway for the infrastructure. So for example, you get metrics about processing load per node. That's a virtual machine, if you like. Get network metrics and plenty of other metrics necessarily that come as part of the standard picture of monitoring. You can get a fairly holistic picture. And one of the key things here is the use of labels all the way through. If you want to identify the cause of something, you need to know which of those metrics actually belong together. So the services are labeled all the way through. So any dashboard that you look at, you'll be able to identify which game's on air and which variant of the game is on air that metric is representing. So tracing becomes a fairly reasonable to do in this world. And then finally, we get into the metrics about the clients. There are lots of different clients out there. As you heard a bit earlier, they do tend to behave a little bit differently. You might have issues with iOS devices, most unlikely actually that one, but you might have some more exotic devices that tend to behave a little bit differently. So we get some metrics back from the client side as well, and that tells us about restarts, things like that. If you've had to restart, it means there's something gone wrong as far as the decode client's concerned, and that there's a bit of a problem with the way it's being delivered. And if it's confined to a particular client, you know one thing, that it's a client-related issue. If it's happening across the whole load, you know it's a generic delivery problem. Um, and we need to understand as well about where we start to have the advertising taking place. So there can be a lot of adverts delivered. So you can imagine you've got 2 million people maybe that are watching a game. They're being served adverts, and these adverts are being targeted at them specifically. You need to be monitoring that too. And so you get some sort of insight into what's happening in terms of the delivery errors. And if you're having a particular problem, you might find that it's because assets are missing. So you send them to a targeted advert, but it's not there. Or there may be a problem delivering it on time. And you can see some of those things happening, right? So in here, there's a big peak that there's one particular instance where those advertising just wasn't happening. It's just lots of issues on that particular advert. And that's down to the fact that the asset was just not there where it's supposed to be. But these kind of user metrics allow you to identify the nature of the problem and identify what the cause is, and it also makes sure that your monetization works. So ultimately, you need to be able to prioritize the subscription protection. So that comes down to things like DRM and making sure the offers are there, making sure you can sign up. But equally, for the advertising side of it, it needs to be making sure that your adverts go out, that you're charging the advertiser for those adverts as well. So that's all part of making sure that the consumer experience works well and the monetization works well. And finally, kind of looking at where we get to in terms of delivery as we move forward into streaming. I think you heard a bit earlier about that triangle of encoding performance, right? So there's the bitrate, complexity, and compute cost interrelated in terms of what you do. When you bring latency into the picture, it's another thing that contends against all of those other parameters that you're trying to balance against. And the reason for that is that as you narrow down the latency and say, I want to have lower and lower and lower latency, it constrains the way that the encoders can operate substantially. And as you get closer to 1 second and below, it really significantly impairs the performance of any encoder. You still have a trade-off to do. You can still balance the different parameters, but overall, the results are going to be worse from an encode efficiency. So either picture quality is going to be worse, your bit rate is going to be higher, or your compute cost is going to be higher. You're going to lose out somewhere. So clearly, we're talking about highly valuable content. We don't want it to go out in poor quality. We do care somewhat about latency. Do we care about, does it need to be an interactive type of latency that you're doing on a Teams call? No, probably not, but it does matter. And we do care about the costs. So the delivery costs in terms of bit rate and the compute costs as well. Compute costs are actually probably relatively insignificant in the scheme of things because the number of viewers are so high. If you look at a Twitch stream, that equation is very different. You kind of really care about those compute costs. So making sure it's the right target for the right market. So if we look at where we are today in terms of streaming techniques, conventional dash or HLS is very good from an encode efficiency point of view. It's highly scalable, it caches well. Generally speaking, it's a very functional way of delivering. Its main pitfall is that it does come with fairly significant latency involved in it. Typically, the client decoder will be buffering something like 3 segments. You may have 1 or 2 more back in the chain somewhere. So just between those things, you're into about 30, 40 seconds, typically these days, with that sort of delay. That's an issue if you're watching and you've got an app open. And most people watching sports do. And quite often they've got one that's associated with the sport they're watching, and they get a notification on it well before they've seen the action happen on screen. So that's kind of it's an experience issue to some extent. You can get a long way to improving that. You heard a bit earlier about getting down to the sub 10 seconds with dash low latency and low latency HLS. They'll certainly get you towards those sort of figures, and that becomes more like parity with broadcast. And it's going to be good for a lot of the entertainment side of the world. And then finally, we've got WebRTC in the picture today. Again, that was something that was covered a bit earlier today. And WebRTC is great if your only real consideration is that end-to-end latency. That's great. It's highly flexible in terms of the client devices it works on because it's all web-based. That's excellent. very, very low latency, but it comes with a shared load of compromises that are a real issue. One is that you need a point-to-point connection between every pair of endpoints. That doesn't scale to 1 million, 2 million, 3 million viewers very well. It's really expensive to deliver. So you probably don't want to do that all the time. Perhaps more significantly, though, for this kind of world, WebRTC in its video guise imposes certain constraints on what you can do at the encoder end. Because it's been optimized for that conference call type world, it said, nope, you can only have a very basic set of tools, encoding tools, available in there. So things like B-frames, for example, are just not allowed. And that's a very simple example, but a whole load of things that preclude you from doing a good job in terms of encoding efficiency and bitrate and quality. So that trade-off triangle is a bit of a problem with WebRTC in its video world. It also doesn't allow you to get access to hardware DRM, which when you're carrying really valuable content is a significant issue. And it doesn't come with things like the usual media interactive tools that you'd expect when you're viewing a video. So being able to pause, go back, skip forward, skip back, you know, that kind of thing. But WebRTC is interesting because it's a bag of bits, right? WebRTC is not one thing that's recently come to light. It's, as you heard earlier, it's 12 years old. It's been around for quite a long time, and it's a toolkit of bits and pieces. And there's a piece of that which is really interesting, which is not the video piece, but it's called a data channel. And it's, seemed to have gone. It's not the slide I expected. Right, let's go that one. That's the one I expected. So WebRTC data channels are an inherent part of WebRTC. They come with every implementation of WebRTC. They're always there. They're nothing exotic in a sense. But where they're interesting is because it's possible to use that WebRTC data channel to pre-populate an application cache that's just providing that segment data available, ready to be played by the player. So that means you can push content through and avoid the round-trip times that cause all the grief with TCP